Hello, and today we're going to be talking about Python's Itertools. So let's just get started here. Okay, so just to set up, you do need to, if you want to do the code that's inside of this tutorial, you'll need to actually import Itertools and import operator just to make things a little bit easier. Actually, to go back, we should probably talk about what iterators are. I think sometimes they are presented as being more complicated than they are. Really simply put, it's just a matter of these are objects that can be iterated over. I know that may sound kind of obvious or maybe not helpful if you don't know what that means. Essentially, they are the types of objects you could put inside of a for loop. So like a list would be a great example of an iterator. So as you go through, think about these objects that we're making and dealing with as iterators. Well, they are iterators, but as iterators in the fact that they're kind of like lists, but they're not lists. If you try to do list-like things with them, oftentimes that won't work. You can oftentimes cast them as lists, though. So not to make things more confusing. We're just going to go into it and go through the iterator tools library. This is in the standard Python library. This isn't something special you have to download. So just sit back, kind of watch these things and see if maybe you might be able to find them to be useful. Okay, so we got your setup. Okay, so the very easiest one here is the count. So the count takes two arguments, a start and a step. So this is actually going to return an iterator that, as it says, make an iterator that returns evenly spaced values starting with the number. So here's a great example here. So for I and Itertools count, and we're going to start at 10, and our step is going to be 3, and then we're just going to loop through it. So we start off with 10, we step 3 to 13, step another 3 to 16, step another 3 to 19, step another 3 to 22. Cycle. Cycle makes an iterator that cycles through an iterator endlessly. Let's see the next example. So here we go. We've got a list of colors here, and then we're going to cycle through with Itertools that list of colors, all right? And we're just going to keep on going. We have a count here just because it does it endlessly. So just for this example, I don't want it to, actually go and have to shut it down. We're going to try to limit it, okay? So here we go. So it's red, orange, yellow, green, blue, and violet up here. That is a list of colors, all right? And so it actually starts going through red, orange, yellow, green, blue, indigo, violet. And once you can see here, it's going to start cycling through one more time. So you can just keep on cycling through your iterator. Okay. Now we are going to go to the repeat. Repeat. So repeat, you're going to give it an object and how many times you like it to go over. The times is optional. So repeat object over and over again, unless there is a times argument. Okay. So our little code example hopefully will make more sense. So here we have food is spam, and then for I and Itertools repeat, we're going to give it food. I'm going to tell it want to repeat 5 times. We're going to print that so it says spam, 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 spam. So if you want to repeat, all right. And if we didn't have that limit, so we put the times here. So in this one we have 5, but if we didn't, it would just start repeating spam for infinity, or at least until we stop it manually. Okay. Accumulate. Make an iterator that returns the result of functions. Sounds kind of complicated. Okay, so we've got these here are from the actual documentation. So this is the actual structure of what it expects. So it expects an iterable, and then a function is technically optional. Okay, so let's take a look here. This is our actual code, so hopefully this will make it more sense. Help it make more sense. I know that definition back here is it's confusing. a lot of definitions for the iter tools are very confusing, but once you actually see how they work, it makes sense. And you get that feeling of like, oh, that's why it's so hard to write these descriptions, because it's hard to describe. Okay, so here we go. We've got a little data list here of 1, 2, 3, 4, 5. We're going to go through their tools, and we're going to accumulate, and then print it all out. Okay, and the function we're going to be using, that's what earlier we imported that operator, and now we're going to do the multiplication. So operator.mul will multiply. You give it numbers, and it will multiply them. All right, so we're going to get 1, 2, 6, 24, 120. And here we can see if you actually put those in the operator.mul, that gives you the numbers you would like. So it starts off with 1. So it's just going to start with 1. And then it's actually going to use the result from the previous answer as an argument in the next run of the function. All right. So our very first run, well, our first run is 1, but then we're going to use that 1 for the 1 here, and then the 2 for here, which is of course going to equal 2. All right. This 2 becomes the first argument and the next run with the 3 from the list. So does that make sense? We're going through this list and multiplying each member of this list with the answer from the previous run. All right. So 2 times 3 is 6. We're going to take that 6 and use that as the first argument one more time and multiply that by 4. All right, getting 24. We're going to do it one more time here. 24 times 5, okay? So you can put any kind of function you want in here. It just is going to have to take the 2 arguments it's going to be given. So it's going to be given the answer from the previous run, or whatever the first value is, and then it's going to calculate it and put it out. So it is an interesting little toy. Oh yes, and so accumulate can also be used to do things like max, right? So max, you give it numbers, and it gives you the max. Which one is max? All right. So here we go. We've got a list with a little bit of jumbled data. So we've got 5, 2, 6, 4, 5, 9, and 1. All right. So first run is 5. As you can see, oh, I ran out of room on my slides. Okay. What we can see. So it's the same thing. Instead of multiplying, we are getting those 2 numbers. Those 2 numbers are running through the max function. The max function decides which number is the biggest and returns that number. So as you can see, it keeps on going. And what's interesting about using a function like the max is that it's going to find the maximum number in this list. I know that sounds obvious, but it's actually just running it one at a time, right, in these pairs. But as you go, it goes from 5, 5, 6, 6, 6, 9. It's not going to ever go down, because the answer for this run of max is used in the next run. So it's always going to get larger and larger and larger. Hopefully I haven't gotten too far off track and it hasn't just totally seized your mind. It's if you look at this, you know what's fun, if you take this code, rewrite it in your terminal, because you can just put this in, idle or whatever, and just run with it. It's very simple, and you can kind of play with it. And I really suggest doing that. You'll really get a feel for it. I really think that Itertools is much more of a library that is better understood by playing with it than by seeing it explained. Despite that, I'm doing this video, so we will carry on. Okay, chain. Okay, chain takes a series of iterables and returns them as one long iterable. Okay, so here we go. We've got a list of colors, and we've got a list of shapes. Ooh, shapes. Okay, so we're going to do itertools.chain, and then we've got these 2 lists, and that will actually make one large list. As you see here, it goes red, orange, yellow, green, blue. Then it goes in circle, triangle, square, pentagon. So it's very useful. There's other ways of combining lists together. This is one of them. Okay, compress. So you filter one iterable with another. Okay, so we're gonna have itertools.compress. We're gonna have our data It's going to be our iterable, and then an iterable of selectors. This is going to be usually some kind of Boolean values. All right, so here we go. We've got shapes. Once again, we're doing shapes. So we've got circle, triangle, square, pentagon, and that's our iterable we're going to be filtering. And then the selector list is what's going to be telling us what to keep and what to get rid of. All right, so our selector is true, false, just alternating. So here we go. We run that through the Itertools compress. So this is the iterator that's going to be filtered, and these are the selectors. So as we can see, the very first one is true, so we're going to keep it. So we output circle. The second one is false, so we are not going to include triangle. The third one is square, so we will, the third one is true, so we will be including square. And then the fourth one is false, so we will not be including pentagon. So it can be, you can use your imagination. There's a lot of ways in which this could be quite useful. Drop while. This is getting into one of the somewhat more confusing, but you know, if you mess with it a little bit, you start to understand what's going on. All right. Hopefully, this code will make it easy. You make an iterator, or it is to make an iterator that drops elements from the iterable as long as the predicate is true. Afterwards, returns every element. Okay. It's confusing. We'll go through it. All right. You realize this definition is actually fairly good. It's just strange. All right. Okay. So here we go. We've got a list of numbers here. It is our data variable. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then goes back to 1. Okay. All right. So we've got a lambda in here. So hopefully you know what lambdas are. Essentially, they're short, tiny little functions. So here we go. Result, Itertools, drop while, our lambda, so our function is going to be, let's see, we want it to be greater than, oh yes, we want, sorry, I got lost myself. It's going to say if they are greater than 5, then we want it to be left in the list, or if it's less than 5, we want it to be dropped, okay? So here we go. We're going to go step through each one. So here we go. 1 is less than 5, so we're dropping it. 2 is less than 5, so we're going to drop it. 3, same thing. 4, same thing. 5 is equal to 5, so we're keeping it. Now here's where the trick comes. With drop while, it stops checking and returns everything else. All right, so everything past 5 is going to be returned. Everything that we'd already filtered out is going to be left alone. And you'll see this represented here. 5, 6, 7, 8, 9, 10, 1. 1 is returned even though it is smaller than 5 because it is the function we're using is drop while. So as soon as a condition is false, it returns everything. You can see here on this bottom area, so we've got 1, it's true, so drop it. 2, true, drop it. 3, true, drop it. 4, true, drop it. 5, false. Now we're gonna return the surviving elements, right? So everything past 5 survived the test, even though some of the elements may not have survived the test if they'd actually been tested, but they were lucky. All right, so moving on. Now group by. Simply put, this function groups things together, okay? It can be a little bit complicated, but it doesn't have to be conceptually. Okay, so we're gonna go back. Okay, so here, my dictionary, my list of dictionaries is list of robots. All right, so these robots have a name and they have a faction. These are all Transformers. And they're all kind of jumbled up. So we've got everybody here from Galvatron, Jazz, Metroplex, and so you've got, you know, Decepticons and Autobots. Okay, you can probably see where we're going. I would like to group this list. I'd like to have them be grouped by faction. Okay, so we're gonna go through here. So here we go, bots. We're gonna use sorted, and we're gonna send that. So this list was called robots. So okay, sorry. Just want to make sure my slides were in order. I was suddenly got a little bit afraid there. Okay. Okay, so first we want to sort them. If we don't sort them, they'll be grouped by chunks. So yeah, they'll be grouped by chunks. Just trust me on this. Just sort them. Everything will work out wonderfully. So we're going to sort this list by their dictionary key, by their individual dictionary keys. So we're going to sort them by faction. So even though they won't be in separate groups, they will be ordered. So right now you can see how it goes: Autobot, Decepticon, Autobot, Autobot, Decepticon. We're going to put all the Decepticons on the top and all the Autobots in the bottom. At least I believe that's how the default sorting will be. Doesn't really matter as long as they're grouped together. Okay. Oh yes. Hey, look, there was an example. I thought this slide was missing. Okay. So yeah, so you can see. Fundamentally, this list hasn't changed, but the ordering has, right? So now we have all the Autobots on top and all the Decepticons on the bottom. Okay, and now here's the group by. Okay, so this is where it gets a little bit confusing. It's so confusing. It's too big to fit on this slide entirely. Okay, we've got another lambda. You see a lot of lambdas in the Itertools, or at least you don't need to see them, but it's where they live. It's like it's their home, almost. Okay, so for key and group in Itertools, group by bots key, and our lambda function here is showing basically we want to access the dictionaries or the key faction to get it, and then we're going to go and we're going to print the key, and we're going to print a list of the group. Okay. Hopefully this makes sense. Okay, here we go. So we run through, it's going to write Autobot because that is the key, and then it's going to show the grouped, this group here. It grouped all of them together, all of the Autobots together, and then it did Decepticons, and then it grouped all the Decepticons together. All right, so let's say you have a list of dictionaries and you'd like them all grouped by a certain value. This is the way you do it, group by. Oh yes, the first group is Autobots, the second group is Decepticons. All right. Slice, or iSlice, iterator slice, is very much like slice that you use in other, like lists. This function allows you to cut out a piece of iterable, just like you would expect. So we've got the standard Itertools iSlice. We've got, you give it the iterable, and then you give it where you want to stop. You can also say where you start and stop, and you can even do a step. All right, so here is my example here for iSlice. We've got our colors again, and we want a few colors, okay? So we're gonna give it the colors list, and we're gonna tell it when we want it to stop, and we want it to stop on 2, all right? Yes, so we get red and orange, all right. And if we want to go forward, we can. So here we go. Let's see, we got yellow, green, blue. So we're going to say 0, 1, 2, right? So we're saying we're going to start at 2 and then end at 5. So 0, 1, 2. So we got yellow, green, blue, and that's going to be number 5. And so that's going to be the little slice of that iterator. Okay. Star map. So we've got our Itertools star map and function at iterables. Makes an iterable that computes the function using arguments obtained from the iterables, which sounds a little bit like our accumulate, but it's not. It's not. We're gonna go back. Hopefully that didn't make you ill as we were going through. As you can see, it's a little bit different. So here we go. We've got a list of tuples. All right. Got these list tuples. And once again, we're going to be using that operator, the multiple operator, operator.mul. All right. So we got the data, and then we give the data here. Ooh. So our function, and then our data, and then we're going to go through each one. So it steps through and gets the arguments from each member or each iteration of that iterable, right? So each iteration of the data iterable is going to be 2 and 6, 8 and 4, 7, and 3. Those arguments or those values are going to be sent as arguments to the operator .mul. So it's going to multiply them. All right. So that's how we get 12, 32, and 21. Okay. So you can have functions being operated on these lists and then getting an iterator back. T. All right. T, return n independent iterators from a single iterable. Yes. All right, here we go. We've got colors. We've got red, orange, yellow, green, and blue. All right. What we want to do is get alpha colors and beta colors. So we use T to do that, and it's going to make 2 completely separate lists. Or iterators, rather, not lists. I try not to say that. Hopefully I haven't been saying that, but what's important is to remember the things being returned by these functions aren't lists, they are iterables, meaning you can put them in a for loop. As you can see, like here, I've put colors, the list colors, into T, and it has produced 2 iterables for me. And then I can iterate over those iterables with the for loop. Now, there's other ways you can iterate possibly through those, but this is the way we've chosen to do it here. So as you can see, they both are identical, and they're both printed out. Yes, so if you want to. Okay, so zip longest makes the iterable that aggregates elements from each of the iterables. Hopefully, let's see. If the iterables are of uneven length, the missing values are filled in with the fill value. So hopefully this will illustrate things a little bit more. That's why I say, like, these definitions are fantastic if you already know what they do. And at least in some of the documentation I read, sometimes they don't have very good examples. So hopefully these examples will make things a little bit more clear. Okay, so we've got our colors again. So we've got red, orange, yellow, green, blue. Then we've got data, so 1 through 10. Okay, and we're going to zip longest these together. Okay, so here we go. We've got colors and data, and our fill value is none. Okay, so we're going to pair these guys up as you go through. So the first time we step through this, it's red and 1. Second time is orange and 2. Third time is yellow and 3. Green, 4. Blue, 5. Now the problem we have here is there are no more colors, but we still have more numbers. This is what zip longest does. So it's put all these together, and it's smart because we've told it what to do. Give all the rest that don't have matching pairs the value of none. So that's what's done here. So none 6, none 7, none 8, none 9, and none 10. All right. Combinations. All right, combinations are cool. It creates combinations. Yes, so you give it a... Oh, there's no sample on this one. Oh, no. But here, you'll see. So we've got shapes. We've got circle, triangle, and square. We're going to do Itertools combination. So you give an iterator, and you tell it how many members you want. Okay? So then we're going to step through and print them out. Okay, so... we've got circle, triangle, square, triangle, square. Hopefully this makes sense. What you're trying to do is get all the combinations of 2-member combinations of this list here. And it doesn't have any redundancy. Like, you could go through and, well, you'll see later. Okay, combination with replacement. It creates combinations with doubles. See, I was going to get ahead of myself, but I stopped. Okay, so it's the same thing. So we've got circle, triangle, square, itertool combination with replacements. Once again, we give it that list, and we say we want 2 members for each one, and you could make that number however you want. It would just be much larger, and your combination would be more. But this does have some doubles here. So so circle can combine with circle. Triangle combines with circle, square with square, and then we have basically every iteration, but not these doubles. Sometimes you might not want the doubles. Okay, product. So Itertools, product You give it some iterables, and how many times you get to repeat. It's going to give it a Cartesian product from a series of iterables. All right, so this will, it's another one that very confusing, but once you actually write the code and you mess around with it, you start realizing, oh, it's not that bad. It's just hard to explain. I keep on saying that, I know. Hopefully it hasn't gotten too annoying. Okay, so we've got number data. All right, 1, 2, 3, and alpha data ABC. All right, we're going to get the result from Itertools product, and we're giving them both those iterables, okay? And these are the combinations we get, all right? So we've got 1, so 1A, 1B, 1C, and then we go to 2, and then 2A, 2B, 2C, go to 3, 3A, 3B, 3C. If you were to structure this out, it would be like a table, except my formatting was all wrong. But as you can see, essentially is a table where, you know, we've got columns of A, B, C, and then 1, 2, 3, and then that basically gives you every combination you could get there. All right, permutations, moving on. Returns successive R-length permutations of an element in the iterable. This definition is painful. Okay, so here we go. Permutations, we're going to just show you the example, and hopefully that will congeal in your mind. You'll feel it. All right, so we got alpha data A, B, and C. All right, so result equals Itertools permutations alpha data. Okay, so this is going to give you pretty much every single permutation you can get with this list. So you can see here. There we go. There we go. All right, moving on. Oh wait, there's nothing to move on. We're done. We're done finally. Okay. Hopefully this was helpful to you. Hopefully you feel like you have a better grasp on Itertools. Hopefully I've not totally and completely confused you. If you like this video, hit that like button. If you want to see more Python tutorials, subscribe. And if you have any suggestions, you know, I'm still working on this channel and trying to see how things go. Yeah, please leave them in the comments. Any comments or questions, I will try to answer everyone in the comments area. But yeah, please leave me some feedback if you wish. Thank you. Goodbye.